I'm going to talk to you about the Foundation Framework. Now, the Foundation Framework contains a whole series of very useful classes which help us develop our iPhone applications. We can roughly divide these classes into primitive classes, things like strings and numbers and so on, collection classes, such as arrays, dictionaries, sets, and utility classes, such as log. And in this video, we're going to focus on the classes that you're going to need to create your first iPhone assignment. We're going to start off by looking at NSString. And an NSString describes a series of characters, letters, numbers, underscores, symbols, and so on. You mustn't confuse it with a C string, and to differentiate between the two in our code, if you put an @ sign in front of a literal string, it's treated as an NS string. If you miss the @ sign off, it's treated as a C string, which is basically an array of characters. You get used to this @ sign in Objective-C. An @ sign is shorthand for this is an object. So when we do NSLog, when we print objects out, we use the @ sign as a placeholder. And when we use NSStrings, we use the @ sign to indicate it's a string object. So here's some ways of creating a string. In the first example, we're using what's called a string literal. It's characters, numbers, letters inside quotes, preceded with an @ sign, assigned to an NSString object. The second example is interesting. Now, if you remember the previous video, when we talked about different ways of creating objects, in this second example, we're using one string. In this second example, we're using an NS string to create another NS string. So we're using the first object, we're calling a method on it called string by appending string, and that generates another string which we store in the name object. So that should make some sense to you. The third way is we can use an NSString class method. Now, NSString has lots of really handy class methods which you can use to do useful things to strings. So we're using the class method string with format, and as you can see, we're specifying a formatting string which contains a percentage @ sign, which is a placeholder for an object. And at the end of our formatting string, we put a comma and the object itself. It's very similar syntax to NSLog. So there's three really useful ways to create NS strings. Comparing strings. It's always tempting to say string 1 object, if name1 double equals name2, then they're obviously the same. Unfortunately, that doesn't work, because what you're actually doing, you're comparing two pointers. And you're saying, oh, do these two pointers point to the same address in memory? Which they may or may not do. If they don't, they still may contain the same string. So there's a special instance method called is_to_string. And you can specify another NS string as a parameter, or string literal as we've done in this case. So this is something to bear in mind if you're comparing strings in your code. Okay, the second class we're going to look at is something called NSNumber. And we know Objective-C comes with a whole series of primitives, int, float, integer, long, short, because it's based on C, so it inherits all those primitive non-object data types. The trouble is, with these non-objects, is you can't use them with some of the more advanced features in Objective-C. For example, when we create an array, our array contains pointers. We can't put primitives in an array, it's not possible. Also, core data can only store pointers to objects. NSNumber is a wrapper which we place around any of these primitive data types, and it means once we've done that, we can put the data on the heap, and we can use that in our core data, in our arrays, our dictionaries, our sets, and so on and so forth. But when we create a number, we have to specify what primitive data type we're using. So here we have two NS numbers, one storing an integer and the second one is storing a float. So there's two ways we can create an NS number object. We can simply call a class method, which basically creates an NS number with the correct value in it, or if you really wanted to, you can alloc the NS number first if you're more comfortable with that particular way of doing things. Either way is fine. And as you can see, we've now got an NS number containing an integer here, and we have an NS number containing a float. We have another problem. You can't use NS numbers to compare with each other. They're just containers. So to be able to do things like comparisons, we have to extract the primitive value from the NS number, unwrap it if you like, and then we can carry out those comparison operations. So it's important to be able to unwrap these NS numbers. And this is how we do it. There's a method called float value, int value, double value, single value. There's one method to match each of the primitive data types. And if you call that method, it returns the primitive value. So I've now extracted my float value and extracted my integer. And as you can see, when I've declared these variables, because they're primitives, not objects, there's no asterisks in front of them. These are C data types. The third object we're going to talk about today is Nsdate, because manipulating dates is really important when we start doing proper programming. And in fact, some of the more advanced tasks in your assignment require you to store dates in particular formats. And Nsdate is an object that stores a date, the month, year, day, and so on. But it's very powerful. You can extract things like the day of the week, you can add and subtract days from dates and months from dates. There's a lot of powerful features. But let's see how we create a simple date which stores today's date. We simply call the class method called date. And the class method called date returns a date object which contains today's date. If you want to get a timestamp out of the system, you can actually call a method called time interval since 1970, and that returns a timestamp which is the number of seconds that have elapsed since January the 1st, 1970. And that's often used for login processes. So you'll know if you need to use one. We can also turn timestamps back into dates by calling date with time interval since 1970, which is a bit of a mouthful. And that returns an Nsdate. So you can convert to and from timestamps Nsdates. The second challenge you might have is, I've got this date object, how do I turn it into a string that I can display in my lists, in my application? Now what we do, we have to create something called an Nsdate formatter object. And the Nsdate formatter is the format that it's going to use to present the date as a string. So once we've created our formatter object, we call a method called setDateStyle. And there's different options to choose from. So this is Nsdate formatter short style, which is a constant, and I'll explain what that means in a minute. And when I've done that, I create my date, okay, and then I call the string from date method from my Nsdate formatter, and that returns a string. Let's have a look at the date styles. So the short style, which is the one I chose before, was month/day/year. There's all sorts of options: medium style, long style, full style. But sometimes you want your own style. You want to change the styles a bit and have something that's more customizable. We call setDateFormat. And we can then specify with great precision exactly how we want the date to be formatted. You can specify the year, 2 4 digits. You can specify month as 2 digits or name. You can specify the day of the week, Monday to Friday, and you can build your own custom date style. The final challenge you might have with date is you might be given the date in a string format, and you need to convert that into an Nsdate object. And we can do that. We simply create an Nsdate formatter which defines the string format that we are using, and then we call a special method called dateFromString, and the method belongs to the Nsdate formatter object. The final object we're going to look at is the nslog. Now, in the first session, if you remember, we used nslog, but I didn't really explain how it worked properly. So now we're going to rectify that. The idea is it belongs to the Foundation framework, and it allows you to print debug statements to the console. Sometimes we need to send actual variables, data, to the console to check the contents of our variables. So we can specify placeholders in our string and then slot variables into those placeholders. So for example, if I put a %@ sign in my string, it is a placeholder for an object. If I put %I in my formatting string, it's looking for an integer for that particular space. A %f is a float, a %u is an unsigned int, and there's lots of other ones. And to use this, we simply specify our string with our formatting in it, And then after that we place commas and we place all the variables in the correct order that we want to slot into those placeholders. So as you can see for the examples, I've got a string object and I've got a score which is an integer. And in my log I want to say player named Mark Tyres scored 500. So my formatting string is player named %at scored %I. And the %at I'm going to replace with name, and the %I I'm going to replace with score. And you can see those two variables after the formatting string. Now hopefully that's been a good introduction to the basics of the foundation framework, and it's given you enough information to be able to do a lot of work in iPhone programming. If you want more advanced information on the foundation framework, there's a second video which you can look at, which it covers the collections. It covers arrays, dictionaries and sets.